All right, today we're going to talk about rational exponents. Now, a rational exponent is just an exponent that is a fraction. Okay? So, if we look down here at this example right here, the square root of 5 can be written as 5 to the 1/2 power. Okay? So we've gone from a radical form to an exponential form. Okay? Now, here we have exponential form to radical form. Now, let's look at how this works. So this is 3 to the 2/5 power. Okay? Notice that the denominator is the index and the numerator is the exponent. That is always the case. All right? So, let's say I have x to the 3/7 power. That is written as an exponent. If I write it as a radical, okay, write it as a radical, then I have x, there's my denominator, so that's my index. So I have the 7th root of x cubed. That is always how that works. Okay? So keep that in mind as we work through these. Okay, so let's look at this here. Here we have, I'm going to write a little bit bigger here, 2/16 to the 1/3 power is just the cube root of 216. And you just go to your calculator, the cube root of 216 is 6. All right? Now, let's take a look at this example right here. Erase that. Okay, I have 7 to the 1/2 power times 7 to the 1/2 power. Okay, you can do that a couple different ways. All right? You can convert these to radical form. So that is the square root of 7 times the square root of 7, which is merely 7. Okay? Now, the other way is you can use your properties of exponents. This becomes 7 to the 1/2 power plus the 1/2 power, which is 7 to the 1st power, which is just 7. So you can see there we get the same answer. All righty? So that's not too bad, but you need to understand the properties of exponents. If you don't remember the properties of exponents, you might want to take a second and review those quickly. Okay? Just look up properties of exponents. Okay. It's one in the simplified form of each expression. So we have 64 to the 1/2 power. So if you look at that, it doesn't look like anything special. But if we write it as a radical, then that means 64. Remember, the index on a square root is 2. We just don't write it. Okay, notice our denominator is the index, numerator is the exponent. So that is just the square root of 64, which is just 8. Okay, so if you're looking at it right here, 64 to the 1/2 power, well, heck, I don't know what that is. Well, if you work it out, it's just 8. Okay, so let's look here. We have 11 to the 1/2 power times 11 to the 1/2 power. One way of doing it would give you 11 to the 1/2 plus 1/2 power. That's our properties of exponents. The multiplication property, okay, or the product property, and that's just 11 to the 1st power, which is just 11. If you convert it to a radical form, this would be the square root of 11 times the square root of 11, which is just 11. Okay, so not too bad. Not really too bad. Okay, let's, I want to move ahead a little bit. All right, now we're going to talk about combining radical expressions. That can be a little bit more complicated. But if you just keep in mind your properties of exponents, and if you're able to convert from radical form to exponent form and then the other way around, you should be okay. So here we have, I don't know if you can see that, this is the fourth root of x cubed divided by the eighth root of x squared. Okay, so I've got the fourth root of x cubed divided by the eighth root of x squared. If I rewrite that in exponential form, I get x to the 3/4 power divided by x to the 2/8 power. Okay? Which means x to the 3/4 minus 2/8 power. That is one of our properties of exponents. Okay, so it's real important that you understand them and remember them. Okay, so if we do the math here, we have x to the, we need to have common denominators, right? So that's going to be 6/8 minus 2/8, which is x to the 4/8, which is x to the 1/2 power. And since we started in radical form, we want to finish in radical form unless it says otherwise. So this is square root of x. Okay? So hopefully not too bad. Now let's go down and look at one of these examples here. I'm going to erase this, get it out of the way. Let's look at A. If we rewrite this in exponential form, this becomes 3 to the 1/2 power times 3 to the 1/4 power. Alrighty? So then that becomes 3 to the 1/2 plus 1/4 power, okay, which is 3 to the 3/4 power once you do your common denominators and everything, okay? So that ends up being, it's already in radical form, so we want to convert this to radical form. The fourth root of 3 cubed, okay? Well, you never want to leave your answer like this, okay? Go ahead and work that out. So it's the fourth root of, I'm sorry, 27. Okay? Now, B, why don't you go ahead and try B on your own, and I will give you the answer. Okay? The answer to B is the sixth root of x to the 5th. Go ahead and work that out and see if you get that as an answer. And then I'll give you C also. C is equal to the sixth root, a big number here, of 16,807. So go ahead and work B and C out and see if you get those answers. All right, now let's move on. Now, the thing about exponents, okay, and I've told you this before, parentheses play a very important part in math, okay? They're very important. They tell us a lot of different things, okay? So what it's saying here is this whole quantity here is raised to the 2/3 power, okay? So sometimes it's helpful to break that out. So we have negative 8x to the 2/3 power. Okay, you can see that. Now we've got xy. Well, it's got a radical here, so that is to the 1/2 power. But then that is also raised to the 2/3 power. Okay, see that? So if I finish this out, this becomes the cube root of 8, that's negative 8, negative 8 squared x squared times xy to the 2/6 power, which is 1/3 power. Okay? Now I'm going to take a look at this. Negative 8 squared is 64. So I have the cube root of 64x squared. And over here I have the cube root of xy. Okay? Now we want to finish. The cube root of 64 is just 4. Okay? So we have 4 times the cube root of x squared, and this is the cube root of xy. And that is A. All right. So I think that's it for that lesson on rational exponents. Now those can be a little tricky, so be careful. All right? Good luck.